All right. Hello. Hi. Hello, everyone. Thank you for joining us today, both here in person and virtually over Zoom for what we expect to be an interesting and timely discussion on a very current topic, how we can support a more affirmative trade policy to enhance circularity for climate change solutions. I'm pleased to be here today to facilitate this panel discussion. My name is Kelly Milton. I'm the Assistant United States Trade Representative for Environment and Natural Resources. I'm here together with my colleague from Ecuador, and we're here to facilitate this panel discussion that is at the intersection of two topics that are very important and trade relevant, the issues of circular economy and climate change. Both of these issues are cross-cutting and are featuring in many discussions here at the WTO. For example, many of you are familiar with the Trade and Environmental Sustainability Structured Discussions, the TESD, which has dedicated working groups on these topics, one on circular economy and one on trade-related climate measures. These discussions have been both interesting and informative. However, the application of a circular economy model to climate change solutions and ways that trade policy can support more environmentally beneficial life cycles for these technologies remains underexplored. Increased resource efficiency and reduced waste and resource use are among the many benefits of taking a more circular approach, including, and perhaps especially, for those goods and technologies that can help all of us achieve our climate goals. What we hope to do here during today's discussion is to delve a bit deeper into this connection in a trade context. In particular, how can we proactively employ trade policy to support increased circularity for goods and technologies that have a nexus with climate change, mitigation, and adaptation efforts? These goods and technologies are often resource, energy, and emissions intensive to produce, yet they are essential to support our respective ambitions to transition to zero or low carbon economies. So we believe it is useful to analyze and discuss some best practices and measures to help improve environmental sustainability and circularity across their value chains. I'm pleased to introduce a distinguished panel of experts today who can help us consider these topics. I'm really looking forward to their presentations and to the discussion that will follow. But before we proceed to the panel, I'd like to turn it over to my colleague, Daniela Garcia, Ecuador's Deputy Permanent Representative here in Geneva, to give brief remarks. So Daniela, over to you.
Thank you very much, Kelly, and it's a pleasure for me to be here sharing the panel, moderating this panel with you, and certainly welcoming experts in this very timely and important conversation, circular economy and climate change. You already mentioned those are interrelated areas and certainly part of the discussion in the WTO. There is a range of climate-aligned goods such as electric vehicles, solar panels, and wind turbines that rely on specific minerals and metals. Spring calls for climate-smart mining, sustainable extraction practices, increased resource efficiency, and also design approaches that promote circularity in the use of those critical raw materials. Certainly, this area needs to be taught through tackling sustainable production and consumption, including reuse, reduce, and recycle. There is conversations about extended product life requirements, repairability, reusability, amongst others, and how product design can facilitate the 3 R's that I mentioned as part of the circular economy approach, and to actually minimize emissions associated with natural resource extraction. Notably, several developing countries rely heavily on exports of raw materials critical to the transition to clean energy, with many seeking to build their engagement in supply chains in ways that enable them to add more value domestically. So there are several important trade and innovation aspects related to this conversation. Others would want to build their own engagement in the development of climate-smart technologies and to participate in relevant supply chains, depending on innovation ecosystems and their policy objectives. Of course, several countries with benefit of access of affordable and effective environmentally sound goods and technologies to their transitions. Circular economy, climate, and trade also need to consider how developing countries can build production, innovation, and international competitiveness in key sectors and supply chains aligned with circularity and climate goals. So upstream and midstream points can also address how trade and trade policy can support accessibility, development, and adaptation of climate-friendly technologies that can support developing countries towards a low carbon economy, and of course, build competitiveness in circular low carbon supply chains. So this is a very timely and important conversation, and as I mentioned, for all of us. And this is a very important area to talk about in the trade and climate interface. There is value added in exploring specific sectors and in exploring this specific conversation today that experts will, that we will learn from experts about. And of course, the trade related aspects that can contribute to a sustainable transition to clean energy. I'm certainly looking forward to learn more from the experts. This is a very technical and important area for all of us. And looking forward to the panel today. We will start with a friend and colleague from the OECD, so Shunta Yamaguchi. Thank you for being here with us. He will provide a high-level frame for our discussion today. Shunta is a policy analyst in the OECD's Environment Directorate. He has done extensive work on the nexus with trade and circular economy and has spoken at the WTO before, including most recently a couple of weeks ago in a meeting of the TSSD, where he presented his findings on reverse supply chains. Shunta is a great expert that has been supporting the initiatives in this very important issue. So please, Shunta, you have the floor. Thank you.
Thank you very much for the very kind introduction and also for the very kind invitation to the Trade and Environment Week and to this event on the nexus of climate change, circular economy, and trade. I have some slides, so while I wait for them to come up, I'll be presenting or giving an exploratory presentation on the nexus of climate change, circular economy, and trade to try to set the scene and to just dive in directly into the topic. Let me see if the clicker is working. If not, maybe if you could go next, please. So in terms of the outline, the first point is, next please, I'll be diving into the nexus of climate change and the circular economy transition. And then I'll be exploring the interconnections with trade. So diving on this first point on the nexus of low carbon and the circular economy transition, next slide. I'd like to start off by recapping on where we stand on global GHG emissions or CO2 emissions. And here on the left-hand panel, we see historic emissions in black. And then beyond, we see some projections into the future. So the red bars or lines show where we will be going with current policies. The yellow lines show where we are bound to go with fulfilling pledges under the Paris Agreement. And the green line shows where we would want to go in achieving net zero by 2050. And this shows that there is some momentum building up in speeding action on climate. However, we also see that we need more ambitious actions to reach net zero by 2050, and this is very clear. Now, turning next to the story on material resources, this is a diagram showing how much materials we'll be using without any additional policies in place, and we will be the amount of resources that we'll be using under the assumption that we don't take additional action will actually double by 2060. So click, please, where we stand. Next, please. Where we stand right now is 79 gigatons at 2011 levels, which, next, please. Next, please. Next, please. I'm sorry for this. And click, please. So this is where we will stand on material use by 2060, reaching 167 gigatons. And with this increase in material use, next slide, please, there will be significant impacts on the environment, which will also double on various ranges. So if you could click 2 times. So not going back, please. So not only on climate change, but also on other ranges, such as air pollution, land and water pollution. And here we see that primary materials are much more polluting than secondary materials. And we therefore really need to think about how we use our materials within our economies. Next slide, please. And here, I'd like to focus on a story of GHG emissions, where without additional policies, click please, this will reach or almost double by 2060 as well. And click please. We know that 12% of GHG emissions are associated with 7 key metals. Also, 12% of GHG emissions are associated with concrete. And finally, around 50 gigatons of GHG CO2 emissions, equivalent emissions, are associated with the material management. And here, if you could just look at the orange bars on the top, like more than half or even almost 2/3 of GHG emissions in CO2 equivalent could be attributed to materials management cycles. Well, therefore, what we can see here is that there are absolute synergies within a circular economy transition that would contribute to climate objectives as well. However, with a more deeper dive, I'd like to go to the next slide, which we tried to unpack this further and looking into various scenarios. And here on the left-hand panel, we see 3 scenarios on blue, gray, and light blue. The dark blue is a material physical reform, which is a proxy of a circular economy transition. Then in gray, we see the energy transition scenario, which is a proxy to a low carbon transition. And the third one is combined effects of the two. And click, please. What we see here when we unpack this is that there are synergies between these scenarios. So if we have circular economy objectives and climate objectives taken together, they will reduce overall material use. And there are synergies, if you can click. So in the areas of fossil fuels or minerals, so these 2 policy areas will go hand in hand. However, this red part on metals, we see that when you take these policies together, the amount of resources that you will need or metals that we need will actually increase. And there are 3 main reasons for this. So the first is that producing secondary materials will actually require energy inputs, and a low carbon scenario actually makes this less attractive. The second point, and probably very important in today's meeting's context, is that the amount of metals that are required to enable a low carbon transition, such as metal inputs into windmills and solar panels, etc., are significant. And therefore, when you would want to achieve or go for a low carbon transition, you also need circular economy policies to support, especially the area of the metal sectors. Next slide, please. Now, turning to sort of the nexus between trade, I'd like to start by the next slide and focusing a bit on what are the technologies that would be focused on. And this is drawing on IEA data. But here we see that for a cost of, to achieve net zero, 1/4 of that would be around for cost-effective technology measures that would be, for instance, on renewable energy or electric vehicles or electrification. And click, please, when on the right-hand panel, I show this more in detail, where a lot of these technologies would be related, for instance, on renewable energy, if you could click once, so such as on solar power and wind power, or geothermal or solar thermal energy sources. For electrification and energy efficiency, this can include electric vehicles, heat recovery, and heat pumps. Furthermore, there could be a lot of developments around energy storage, such as batteries. And also, this could also include emerging technologies such as hydrogen applications in the very bottom. So, and these technologies are rather recent and still haven't reached their end of life phase that will need recovering of resources as well. And I think this calls for a possible need of trade solutions to help achieve economies of scale for these materials to be better used in these sectors. Now, next slide, please. So I'd like to touch upon the broad linkages between trade and circular economy. And here we have a linear economy where we produce, consume, and dispose products when they reach end of life, and the circular economy aims to close material loops such as through recycling, higher value loops, if you can click please, higher value loops such as refurbishment, manufacturing, reuse, and repair. There are other areas more upstream such as eco-design policies and product service systems in place. And this often happens within national boundaries, but there are important linkages with trade and three pillars. The first is on global supply chains. The second one is on end-of-life value chains, such as trade in second-hand goods, trade in refurbishment for manufacturing, trade in waste for recovery, and trade in secondary raw materials. The third pillar is on trade and services, as the circular economy transition has high service sector involvement. And there are several issues that we want to touch upon. If you can go and click on these points. The first is how the circular economy transition will have an impact on trade. The second is how to secure policy coherence between these areas. The third is to understand the nature of trade in waste, secondary materials, and secondhand goods. And the last point is around the role of international cooperation. On this very first point on how the circular economy transition impacts trade on the very left top-hand corner, we did some modeling analysis on this. I'd like to show it in my next slide. And this is under the assumption that the circular economy transition will happen globally. And we show outputs in blue and exports in gray. And there are two stories to tell here. So on the very left-hand side, you see that aluminum outputs will be reduced by over 10%. However, exports will increase by over 10%. And this tells a story that material production as well as export bases will become more specialized. On the very right-hand side, we have outputs for the recycling sector, which outputs and exports will both increase. And these two, I think, tells a story that trade has a role to play in enabling a circular economy transition. To tell the story in a different way, next slide, please. We tried to unpack this into scale effect, efficiency effect, and trade effect. And clearly we see that reducing material use will require a substitution, efficiency, and trade, as shown in the light blue bars here. So next slide. These are my two final slides. And what do we want to do from here? Where do we go from here? So some issues for consideration. And the first point is that trade has a role to play for a circular economy transition by help achieving economies of scale. And therefore, trade impediments for circular business models really need to be addressed. But at the same time, trade leading to any negative environmental consequences need to be avoided. And how to strike the right balance is really, really hard at this issue. The second point is that circular economy concept should extend to supply chains and ensuring an environmentally sustainable and just transition for the extractive sector is very important. The third point is that circular economy opportunities for end-of-life value chains appear to be mixed, and there appear to be some promising areas such as secondary raw materials or goods for refurbishment manufacturing, where the end use is fairly clear. However, there are challenging areas with potential trade-offs between economic efficiency and environmental protection, such as trade in waste and scrap and trade in secondhand goods, which need more work in this area. The next point is that trade in services also appear critical for a circular economy transition and circular business models, which require the movement of people, information, and data such as for repair or such as maintenance activities or end-of-life solutions. And finally, better transparency and traceability is needed for trade to work for a circular economy, which takes me to my final slide. So for a mutually supportive agenda, the first point is that promoting trade in environmental goods and services for a few points that appear to be ways forward, such as goods for recycling and waste management, also secondary raw materials and goods for refurbishment manufacturing, which I said where the end use appears to be fairly clear. On the second point on definitions and classifications, this is a very complicated area where there's a patchwork of different definitions and classifications between countries, and which the harmonized system codes such as on waste, secondary materials, secondhand goods, and goods for refurbishment manufacturing. And trying to clarify this is also an important area to work on. Third point around standards. So standards, there could be harmonization and mutual acceptance of circular economy related standards or conformity assessment procedures that could be coming up in the next few years. Also, cooperation towards developing common standards is also an area that we can keep an eye on. On regulations, also several points to make. So first bullet on extended producer responsibility schemes. We want to ensure how these schemes take in account of end-of-life value chains, especially second-hand goods exports. Also tackling free riding from online sales. The second point on supporting cross-border reverse supply chains, such as ensuring the swift implementation of prior informed consent procedures under the Basel Convention and OECD decision on transboundary movement of waste. Finally, tackling illegal waste trade and removing trade restrictions where possible is also important areas. Finally, on the areas of further cooperation, there could be roles for aid for trade, trade facilitation, digital technology and innovation, and also upstream cooperation such as eco-design, as well as emerging efforts around product passports. So I know this is a lot of information to digest, but I'll stop here. Thank you very much for your attention, and I'd like to hand the floor back to the moderators.
Well, thank you. Thank you very much, Shunta, for that extremely helpful and informative scene setter, which very clearly framed and demonstrated the link between trade and circular economy. So next, I'd like to introduce Dr. Nabil Nasser. He's joining us by Zoom. Director of the Golisano Institute for Sustainability and Associate Provost for Academic Affairs at the Rochester Institute of Technology in New York. Dr. Nasser has worked in sustainable manufacturing, remanufacturing, clean production, and sustainable product development for over 25 years. And he is considered an international leader in research and development efforts in those disciplines. Dr. Nasser, please, over to you.
Well, thank you very much for the introduction, Kelly, and it's a pleasure to be with you today. I hope you can hear me okay.
Yes, we can hear you.
And you can see the slide?
Yes.
Okay, excellent. So I apologize for not being there with you. I am at a unit meeting in Paris this week. So it's great to have this discussion after my colleague, Mr. Yamaguchi, presented some really wonderful articulation of a lot of the issues that we deal with in circular economy, specifically related to trade. My presentation is focused primarily from an industrial system and from an industrial perspective. And I just want to start by addressing some of the roots to some of the interests that we have from an industrial perspective in circular economy. And then I will highlight some of the trade challenges that we face that we think are obstructing our ability to actually move forward with a lot of circular economy implementation. This is this chart that I'm showing here actually from work that I did with the OECD way back in 2010. And I think you can see here the progression of our thinking from an industrial perspective from that we move from pollution control to cleaner production thinking, to eco-efficiency, to life cycle thinking. Ultimately, the goal for us from an industrial perspective is to go to a closed loop production system. That closed loop production system is what we call circular economy today. And the bottom line, from an industrial system perspective, this is where we bring the product back. This is where we can do a lot of circular processes. And this is also where we manage a lot of the natural resources that go into making the product and ensure that we actually have a system to allow for the recovery of this material through recycling, or for extended life of many of those products and many of those material, multiple cycles, which would help achieve many of our goals. So this is kind of an industrial system perspective. In 2011, I was joined by several people that actually were focusing on developing that first book on circular economy that was commissioned by the Ellen MacArthur Foundation. And really, the goals that we have in this area and the reason we are focusing on circularity is that because it results in an improvement of resource efficiency in terms of the use and the unit life. It also results in decreased systemic energy and waste generation. And it also helped decrease resource use from energy to virgin material. And lately, we've been really talking about regenerative system, a system that contributes to ensuring that we actually, there is a cradle-to-cradle approaches to what we do in the industrial system. So circular economy became, thanks to the Ellen MacArthur Foundation, became a very important topic of discussion, and also, part of our objectives in the industrial system. So you're all familiar with the linear system. I think you heard about that, but I just want to, and I was pleased to see, in a lot of the depiction of what a circular economy is, many times the word even remanufacturing is not used, even though it is a major part of what we actually look at from a circular economy perspective. So the key here, from an industrial perspective, from product system perspective, we're trying to have that closed loop system from repair to reuse to refurbishment, remanufacturing, and recycling. And just think about that from a trade point of view, some of the challenges that we face in implementing those processes. And I'll talk about that here in a few minutes. So a few years ago, my panel, the international panel, international resource panel, I was commissioned to work on a study that helped to quantify the value of circular processes in manufacturing. And the goal for us is really to help develop some guidance to policymakers and decision makers as well. So with that project, actually, we dive very deep in a lot of the challenges in the circular processes. And we ended up basically in this report developing a term which I called it value retention processes. So compared to recycling, where we bring the material back to its original form, so recycling processes, value retention processes are remanufacturing, refurbishment, and repair, which maintain the shape and form of the components, and basically through that you realize significant value that in recycling we basically burn it. Here in this case, actually we retain a lot of these values that result in significant saving from material cost to the capital equipment costs that made those components, to the emission associated with the mining for new materials. So that report highlighted quantified the value of all the circular processes. We looked at 4 sectors. We studied that in Germany, US, Brazil, and China. So there was extensive work to quantify that, especially for policymakers who wanted to be convinced that this actually can result in significant economic value, and including labor force generation and so on. So one of the key factors that was clearly identified in the study as a key enabler for implementing remanufacturing strategy is remanufacturing. The reason for that is remanufacturing basically brings significant economic value. Remanufacturing, for example, in many countries is never subsidized. It has basically economic advantage. So basically, what I call is remanufacturing is a gateway for recycling, because you develop a system that allow you to bring the product back, and what you cannot reuse, you end up basically sending it to recycling stream. So it is a gateway that really facilitates that reuse of products or remanufacturing, as well as also recycling, so that separation and disassembly techniques that we use. Clearly, from a business perspective, we use less raw material, significantly less. In some cases, 80% less. Some cases, it's 90% less material than to make the same product that meet the same quality, reliability, performance as brand new product. And this is what we call the primary condition for remanufacturing. It has to get the product back to like new condition. So it is not refurbishment and it's not repair. It's really the ultimate form of actually bringing the product back to like new condition. Obviously, it has lower costs and higher margin for the manufacturers, and lower costs for the consumer. And basically, it allows for many companies to meet their environmental objectives and so on. From an environmental point of view, it's reduce greenhouse gas emission. It conserve up to 80% of raw material, sometimes higher. It offsets the energy demand for the companies. So in any case, in general, it has significant advantage from a business perspective as well as environmental objective. Now, just give you a snapshot of what goes on in remanufacturing using US as an example. The military sector in the US is the largest remanufacturer in the world, from aircraft to ground vehicle to Navy ships and others. It creates 180,000 jobs in the US, and this is old data. I think the number is higher today. The aerospace is the largest sector, non-military sector, and we have roughly 13 very well-recognized sectors in the US. There's a consumer product market is growing in terms of the existence of remanufacturing. And by the way, when I say remanufacturing, many of those companies also refurbish products. So you can see the sectors here at the bottom, from locomotive systems to furniture to medical equipment to automotive and many others. So one of the things that I just wanted to highlight is the fact that from a technical perspective, we continue to make products that are more durable, that last longer, but there are part of those products that the technology continue to advance in much higher rate. Think about hospital equipment. Those machines that do a lot of those analysis, you end up making the product, and eventually at the end of that cycle of use of that product, many components of this product end up basically going to another cycle through remanufacturing process, where you upgrade the machine with the latest technologies. Some of the components end up going to recycling, but many go back to remanufacturing. So this cycles can go up to like 9 times in some cases, because many components are very durable and last very long. And the key here is that it gives you significant ability to upgrade and provide the consumer with the best product for a fraction of the cost of what a new product would cost. This is a map of the remanufacturing sectors in the US. You can see here it's significant in the US. And the reason for that is that we don't really have a lot of restrictions in the US. Many other countries, actually, there are a lot of restrictions. And this is a slide to show you, for example, from the study, the UNIP study, you can see here that from an environmental impact per unit, you can see here the embodied energy. The first grouping here is for making the product brand new compared to remanufacturing. You can see here the embodied energy used in making the product is significantly less. When you go to the other side, you would see from a material extraction or material impact, you can see here making the product brand new, that blue bar shows significantly higher material consumption in making a brand new product versus in the second grouping, that's a remanufacturing group. So you can see here why the energy will be higher, because it's associated also to that high use of materials. Now, just my last couple of slides here. This one here showed the analysis that we did in terms of the barriers to implement circular processes, and we studied 4 countries. And you can see here the color coding here: no barriers when it's green, significant barriers when it's red. You can see here that was very independent scientific analysis. You can see here the first grouping talks about regulatory and access barriers. And the conclusion is that if you do have regulatory and trade barriers, there's nothing else matters. All of the other barriers don't really matter. It's, that blocks the ability of that economy or that country to actually accept or develop a circular processes or circular economies there. So you can see here in the US, we still have a lot of market barriers because that's consumer perception. You can see here what it is in Germany. You can see in China, for example, while there's a lot of openness now for domestic remanufacturing companies in China, but it's still very limited. And then my last slide is, or actually one before last here, it talks about some of the mechanism for enhancing circularity. Some of it will be at the company level where you have to invest in technology development. You have to focus, you have to modify the design processes, and then the external factors where we have investment in R&D. This is typically at national levels. Open market access and trade is huge one as well. And then the standardized data, as Mr. Yamaguchi also alluded to, are some of the major factors to consider. There's a lot of issues also about market acceptance, and those also are some of the barriers that we face. And I thought at the end here, just the last slide to summarize from a very simplistic, and this is issues from an industrial perspective, the issues that we consider to be significant trade barriers, which is the core access and trades. The core is the end-of-life product that we bring back to remanufacture or refurbish. There's significant barrier for obtaining that core. There is also waste definition that continue to evolve that threaten our ability to bring this core back to a facility where we can do that work, because consider it to be waste versus a product that is ready for processes to bring it back to life. There is also tax surcharge on core deposits, which is a complicated issue, but the bottom line is that we provide the consumer with incentive to get the product back, and that called core deposit, and that is inflated to be able to bring the product back, and that there's some taxation on that make it difficult to extend that leverage. Market access for circular products, that's related to import restrictions. So many countries would not allow the importation of those products. And also there is the classification of circular product, remanufactured, refurbished product as used. And that also has significant implication on trades and open market access in this area. So with that, I think I'm gonna stop here and turn it back to Kelly.
Great. Thank you so much, Nabil, for that really interesting presentation, providing some tangible examples, particularly in the remanufacturing area, and really outlining some of the trade challenges that you see in that particular space. Finally, I'd like to turn it over to Dr. Jeff McCarney, who is an assistant professor of environment and development at the School of International Development and Global Studies, and director of research for the Institute of the Environment and the Smart Prosperity Institute at the University of Ottawa in Canada. Jeff has done extensive research on environmental, natural resource, and development economics, including on climate change impacts on natural resource use and end-of-life value recovery considerations for solar and wind energy technologies. So Dr. McCarney, over to you. Thank you.
Thank you very much. And I've just tried to share my screen. I hope that's working.
Yes, it is. Thank you.
Perfect. Okay, thank you. It's a pleasure to be here. I really appreciate the invitation to speak today and also to speak with the other panelists here who have actually inspired a lot of and them and their organizations have inspired a lot of the work that we're doing here in Canada on these topics. I want to start off by just clarifying, I'm not a trade expert. I'm a resource economist. I work also in climate science, climate, environment, circular economy policy here in Canada. But I'm going to highlight work that we've done that we think has important trade implications and other policy implications and try to speak to those a little bit at the end as we move along. Oops, I didn't advance here. There we go. But I'd like to start off just by, instead of pointing to a definition of circular economy, we've seen one earlier, but I think it's helpful to get a sense of how stakeholders in the sectors that we're looking at think of the term circular economy. And we do a lot of thinking about what it means to be a resource producing nation or economy in the transition to a more circular global economy. And we've asked this question, what does circular economy mean to you? This is response from stakeholders in the mining sector, working with both NGOs, human rights groups, major mining companies, policymakers, and Canada researchers. And what we see them come up with when we ask them these questions are they highlight that circularity is related to value creation, opportunity, and systems thinking. They point to things you would expect, such as reducing waste, using waste as a resource. They point to things like reducing impacts, reducing consumption, and improving resource governance and stewardship. These are all things you would expect when you hear circular economy. However, we also see them point to a lack of clarity around what it actually means for them in the sector. Questions about risk for the sector. I think we've seen some of that in some of the earlier presentations. I'll speak to that a little bit more. And that is going to require them to transform their business models in a way that they're really not sure what it's going to mean for them, their sector, or the future in that regard. And some of these questions that we're really trying to dive into, and I'm going to summarize today. I think a lot of this gets captured in the way we think about the circular economy. And I'm going to show a couple of models here, not to dive deep into what models of circular economy is, but just to show how they tend to be represented. So this is one from a leading Canadian group that focuses on the circular economy. And it looks like we come to expect. We have resources flowing into the system. We have increasing loops of recovery, reuse, remanufacturing, recycling as you move along a linear value chain to try to increase circularity and reduce waste coming out of the system. What I want to do, though, is just focus on the left-hand side. And what we tend to see in these models is that resource extraction sectors, so primary resource sectors, they're on the periphery of the models, and they're just focused on something to rethink and reduce consumption from, or flows to be minimized. And that makes sense if we're talking about circular economy. We're trying to recapture waste, reflow value through the system, and reduce our use of primary materials. However, we've delved into this a little bit further. Here's another representation. This is from the European Environmental Agency. And again, we'll see that resource extraction is a flow to be minimized on the outside of the sector. Once you get into the circular economy, you're looking at eco-design, distribution, consumption of stock, waste, recycling back to core materials. And we argue a little bit that this perspective comes from tradition in circular economy literature that it's really been driven a lot by resource importing economies. Initial roadmaps for circular economy come from China, which is a leading resource importer, Japan, South Korea, the EU, EU member nations like France, Netherlands. You also see from Finland. You have an increasing number that are starting to come from countries outside that group, Chile, Australia, Asian nations, Canada's working on one. But they also still tend to stick to this frame of looking at circularity downstream of primary extraction. The resource sector is something to be minimized. What we're trying to do is design new products, reduce waste, reduce demand for primary resources. And without challenging that, it leads to a particular way of thinking about the problem, which we've been trying to dive into a little bit more to understand, well, is this really the risk and challenge that it seems to present for resource producing economies? Are they something that's going to be minimized in a global transition? And this gets me to sort of a weird situation where I'm presenting the work that's been done by the organizations that my co-presenters are from. So this is a summary that we tend to look at, highlighting OECD material projections through 2050. This is some of the work that Mr. Yamaguchi presented earlier, as well as United Nations Environment Program International Resources Panel projections. And this is highlighting sort of what we saw in the earlier presentations, that resource demand is projected to double by the OECD by 2060. UNEP International Resources Panel has similar projections. If they look at accelerating resource efficiency measures, really ambitious resource efficiency measures, they shaved that number by about a quarter. And even in the OECD numbers, I think it doesn't get emphasized enough, but it's relevant to point out, these are some of the bars that we saw Dr. Yamaguchi flipping through earlier. The resource doubling number actually already factors in fairly ambitious resource efficiency measures. I think it's 3 times recycling rates over that period, increasing of remanufacturing by approximately doubling, and structural change in the economy of service sectors. If you don't include those, you're looking more like a 3 times increase in material requirements. And this is driven by population growth, increasing numbers of middle-class consumers in emerging economies, and structural change in where things are produced and the resource efficiency we can expect. One thing it doesn't include, though, which is really interesting to dive into in the context of this, at least to my understanding, is a lot of these numbers are based on the IEA's current policy scenario, which doesn't get us anywhere close to 1.5 or 2 degrees. That's holding climate policy steady at what was in place around 2017, and not including anticipated policies and not including anything that would realistically get us to net zero, 1.5 or 2 degrees. And this is important because we look at leading work on the material requirements to get to a low carbon transition. This is from the World Bank. We need increasing amounts of materials to do that as well, over on top of some of these other projections. So if we're looking here, battery metals like cobalt, graphite, and lithium, 400 to 500% increases versus what we were doing in about 2017. Vanadium and nickel also for storage, looking at 100 to 200% increases. Silver and indium for solar panels, between 50 and 200%. Neodymium for wind, about 50%. But also some of the smaller numbers here, aluminum, copper, lead. These are major metals, and small percentage increases are actually very large aggregate increases in the material requirements that we're looking at. And this adds on to some of the numbers that we've been seeing in the other presentations. And that's because renewable energy technology is just much more material intensive. And so I think it's important to clarify then that when we talk about adding circular economy policies on top of some of the projections for material requirements for climate solutions or low carbon, this is a figure from the World Economic Forum, just to use another source other than the organization my co-presenters are from. What we're talking about is reductions off an increasing baseline. And it's not at all clear that that means overall aggregate production, overall reductions overall. So from the World Economic Forum, if we look at projections of iron ore evolution, which is a major component in steel, going forward to 2050, we have increasing demand, slightly reducing demand as China's steel consumption slows. Recycling regulation policies coming into effect, but taking time to take charge and taking time to generate enough material to displace primary demand, so that by the time we get to 2050, you still have greater demand for primary resource than we do today. You have a significant bulk of material you need in between there, and just an increasing wedge of the difference between today and what we're going to require covered by recycled material or recovered material. This is another figure from the World Bank showing the same problem for aluminum, looking just at requirements for low carbon to get to 2 degree scenario through 2050. And so just for low carbon energy, secondary aluminum can meet 61% of the demand in 2050. And that is assuming 100% end of life recycling rates, which is probably unrealistic to assume. But assuming we can get to 100% end of life recycling, secondary aluminum can meet 61% of the demand increase. We still have an increasing wedge of primary material required. So the implication of this is we need to think about the nexus between circular economy and climate and trade in the context of not just minimizing primary resource extraction, which we absolutely want to do, but it's really a context of how are we blending primary extraction with increasing secondary material recovery through recycling, remanufacturing, end of life, to meet the material requirements that we're going to need, particularly for a low carbon energy transition. We want to increase our ambition on that, not hit roadblocks because we don't have the right materials, as well as the material requirements for that we see from other sources, increasing middle class consumers' population growth. We've done a little bit of work just trying to model what a renewable energy transition in Canada looks like and the material requirements we would need for that. And so it's limited in the context globally, but I think it's illustrative, just sort of showing how we had to think about managing the problem. And if we look in Canada, even conservative scenarios of renewable energy technology uptake to get us towards our climate targets show 60-fold increases in accumulated end-of-life solar PV modules and 30-fold increases in end-of-life wind turbines. That's by 2050. These technologies, as I mentioned, they require more materials per unit of energy generation compared to fossil fuel-based technologies. They also use critical and strategic minerals and minerals, which are subject to near-term economic and geopolitical supply constraints. We need to figure out how to sustainably supply those so that we can meet our climate ambitions. That includes 13 of 31 minerals designated as critical by Canada because of their importance to economic growth. And if we project these going forward, we can look at projected requirements. Here we're using models from the Canadian Energy Regulator to look at solar and wind capacity projections for Canada. These don't get us close to meeting our net zero commitments by 2050. These are based on emerging technology scenarios, not on what gets us to net zero, but it's still illustrative to see the volumes that we're looking at. And we can look at projections of installed capacity, the green line. We can then break that down into component parts and look at the material components of that. And based on end-of-life assumptions and whether you see faster or slower loss rates, depending on what the industry projects, we can project from there the waste volumes that are going to emerge over time. An interesting part is you see the lag in terms of installed capacity versus when we start generating waste, because that's dependent by the lifetime of the system. The more we apply circular economy principles to increase lifespans, the longer it's going to take to get that material back flowing through the system again. And there's important economies of scale to consider here. In talking to the industry, they highlight for us that to really have viable private sector recovery and recycling of solar panels, you need about, I think, 10,000 mass tons per year generated to make it economically efficient. Currently, we don't get to those numbers across Canada until you get to about 2034, 2035. So that really highlights that for us to do in Canada do this well, we're going to be looking at regional systems. We're going to be looking at cross-border trade with the US and trade in decommissioned solar panels, trade in recycled materials to really get to the economies of scale we need to generate the resources. We see similar trajectories with wind waste. I won't get into too much detail on it. The main point I want to highlight is that the materials you generate actually depends on technology assumptions that we make. If you think about solar panels, whether you're using first or second generation solar panels, they have different material components. They use different metals and minerals. They use different critical metals and minerals. And if we model different trajectories of how that stock turns over, we get different projections for the material requirements that we're going to have over time, which can also have implications for how much primary versus secondary material we have access to, where we're sourcing that material from, how much we're reliant on trade relationships versus how much we can source domestically. And the same thing in terms of what we're supplying to our export partners. We see the same thing for wind, particularly in the case of rare earth elements for wind. We see similar things emerging depending on whether we're using direct drive or gearbox wind turbines and things like that. And we've done some really simple modeling just to say, okay, well, if we just stick with the renewable energy sector, what does potential material recovery look like? And we just made some really simple assumptions based on estimates of current material recovery rates. We call it recycling rate, but this is really just material recovery rate. It could be recycled, it could be remanufactured, it could be reused as long as it circles back into the sector. And then we just assume, okay, what if we go to, we don't know what future potential recovery rates are, we're just going to assume 100%. And we look at a reference scenario, we look at a slow technology turnover scenario, moving from gearbox to direct drive wind, moving from first to second gen solar, or an ambitious stock turnover scenario where we do that quicker. And what we can see is, moving through time, 2030 to 2050, as you move back, we're really only looking at potentially recovering 20%, maybe up to 40 in some cases, of the material that we need to continue moving towards renewable energy and low carbon energy generation. The only times where we start to peak up towards 60 to 80% are scenarios here where we have ambitious stock turnover, and what's happening is the second generation technologies don't use as much silver as in solar as the first generation technologies, don't use as much tin. So we have a bulk of material that's actually not required for the latest generation technology. So that works its way out of the system. Otherwise, we're looking at a combined scenario of merging primary and secondary sources to meet the demand requirements, and we'll have to figure out how we're sourcing those. So what this highlights for us is that there's a real need to strategically consider the investments, policies, and I would add trading relationships needed to sustainably and reliably manage the material requirements of this kind of low carbon energy transition in the energy sector, and you could look at other sectors as well. And it needs greater attention beyond just resource recovery at end of life to thinking about what materials will be required to meet low carbon energy demand. What technologies are we adopting? How do those impact the mix of primary and secondary materials that we're required to access, and the environmental and geopolitical risks of obtaining those materials? Where will those materials be sourced from, and how are they produced? What is the overall environmental footprint of them? Can we selectively use different technologies or different roadmaps to get to a low carbon pathway that will have greater or less environmental impact depending on the resources we're using? Because again, we can't just rely on secondary sources to alleviate the environmental impacts for us. What risks exist along key critical and strategic metal supply chains, and will certain adoption of certain technologies lead to risks which might slow a low carbon transition because we can't access the materials we need? We don't have enough secondary supply, and the primary sources are subject to geopolitical constraints. And then you also add on to that how we handle material recovery at the end of life. How much secondary material can we recover? What is a reasonable recycling or recovery rate to project? And how do we handle disparities in regional access to those? We hear a lot in Canada from Indigenous communities which have gone to dispersed energy generation, solar and wind panels, and they have difficulty handling end of life because they don't have access back into recovery chains or waste management chains because of their remote location. And there are things we have to consider. And then we have to think about the fact that these waste streams will be dynamic and changing over time. If I'd given this talk a year and a half ago, I would have said we can't recover wind turbines. They're not recyclable. There's now new technology that allows us to do that, and that's going to be changing constantly as we move forward. So I wanted to end just with a couple quick reflections. I was also asked to speak to a few technologies and examples of things we see happening in the sector around these observations. Key emerging trends we see in metals, mining and minerals, given the fact that we need to think about how we're aligning primary and secondary production going forward, is what are key drivers of circularity for upstream production of primary resource extraction? What does a primary resource producer that's operating in a circular economy or circular value chain look like? And we see things like electrified mining equipment, technologies to improve production efficiency, technologies to increase capture from byproducts, markets and equipment for sharing and rentals, the overall material use in extraction, and increasing industry collaboration. One of the most interesting things we observe is that a lot of the industry partners we work with in mining view circularity as a space for pre-competitive collaboration. They view it as a sector-wide problem of perception of the sector, not an area where they necessarily want to compete internally to the sector. They view it as something where there's space for pre-competitive collaboration, sharing, learning, and innovation. A few examples then of things we see. So these are examples from a review we've done for the Trade Commissioner Service in Global Affairs Canada. And just different companies who are doing things in this space. Now, we're not standing behind any of these companies, or we're not promoting them. It's just the idea of seeing things that are happening in Canada in terms of innovations that could be called circular. Idean Technologies is using detectors and imaging systems to reduce the need for exploration, reduce the impact of exploration, and increase the lifespan of mines so that you're not moving on across the landscape. Environmental Technologies has chemical technology to extract metals from mine concentrates as well as secondary sources, reducing the use of contaminating pollutants. EnviroGold is using electrochemical and ServicePro technologies to recover greater amounts of metals and minerals from residual waste and tailings. I have examples of where they're exporting some of these solutions currently globally. But I think the point is there needs to be a discussion. This is part of what our work with the Trade Commissioner Service was about, is what qualifies as a circular technology in this case, in the mining and metal space, but along other value chains as well. If our Trade Commissioner Service or our trade commissions are trying to highlight circular export potential, what should count within that range? You could challenge whether these should count as circular technologies because they are advanced upstream in the extractive sector. But there are other technologies as well that maybe these ones fit, but others don't. And we have to think about what counts as a viable technology that should be promoted in trade agreements and what counts more as greenwashing or perhaps not moving in the direction we want. And it's going to be important for thinking about standards, for thinking about what falls under different regulations and trade agreements and how we move forward in this regard. So then just a last note about where we think about broadening recommendations for circular trade opportunities. I tried to think about different things here. I didn't want to repeat the great work that I've seen done by Dr. Yamaguchi and others. And some of the things we see are real need to conduct deeper sector analysis and market assessments to understand sort of what this balance between primary and secondary potential solutions look like. How far can we get with improved design in secondary material generation? How much are we still going to have to rely on more linear production processes to feed into circular value chains? One area we see this is really relevant right now, whereas Canada, the US, EU, and UK are all developing critical strategic metal strategies. How can circularity be integrated into those to make sure we're moving in the right direction? This links more to prior examples we've seen. We want to identify financial, regulatory, and technical barriers for going circular trade, and how existing trade agreements as well as new policies can be designed to overcome these. We want to build partnerships to create supporting regional ecosystems for circular innovation, and this is to enable investment, trade, and economies of scale. This gets back to the idea of economies of scale and recycling infrastructure. Do we have enough volumes in local regions or nationally to reach those economies of scales, or can we rely on regional systems to generate the volumes that we need to recover material effectively? And the last thing is we need to continue to track clusters of circular economy business solutions to understand what should qualify as a circular innovation, to ensure alignment and clarity of standards, taxonomies. Certifications, I think, are really interesting. We're seeing a proliferation of certification schemes, both internationally by industry associations and by leading industries and by leading industrial, large-scale industrial companies themselves. And how these merged together are clarified in terms of what should count as circular, what shouldn't, what will flow, be recognized in trading agreements and what won't, will be really important in terms of how we move forward and reduce frictions. So that's it for me. I'm going to stop there. So I think I went 1 or 2 minutes long, but I hope that was helpful, and I look forward to the discussion.
Well, thank you, Jeff. No, that was extremely helpful and very informative, really connecting the threads between circular economy and the clean energy transition and the questions that we need to be asking ourselves and others. So no, thank you for that. And really a thank you to all our panelists for the excellent presentations. I think before we open it up for questions from the floor or from the Zoom, I think Daniela and I both have a couple of questions to kind of set the stage for that. There's just so much to unpick from the presentations, but one thought that we've been also thinking about is the fact that, you know, there are a lot of discussions regarding, you know, the nexus of trade and circular economy, and oftentimes it's focused on the upstream, so the design, or the downstream, the end of life of these products, but there is not necessarily a lot of discussion about supportive trade policies for the permutations of the different technologies in between. So I'd be interested if any of the panelists have some thoughts or perspectives about, you know, gaps that we as trade officials might seek to address there. I don't know, Shunta, if you'd like to start. Thank you.
Yes, thank you very much, Kelly, for the very interesting question. I actually found this question very tough and tried to answer them to my best, but I do think that Trade and Circular Economy Nexus has focused a lot, perhaps on end of life, and then focusing more recently on upstream and design issues. But I do agree that this needs to cover like the life cycle of the circular economy solutions as well. And maybe this turns back to a little bit about what Dr. McCarney said in his presentation, that a lot of these technology solutions are rather new and they haven't reached their end of life yet, and they need to, for instance, this could be for batteries or renewable energy solutions, or perhaps something more recent, such as on hydrogen applications. But a lot of these technologies are new and the trade flows might not be significant today. But as we look towards closing the loops for these, we do need to think about how trade would function and how to keep the door open for trade to enable those solutions at economies of scale. I also think, turning a little bit about also on Dr. McCarney's intervention about how do you qualify something as circular and what do you not qualify, and for instance, this would qualify as greenwashing. I think we really want to have more granularity on what trade flows we want for a circular economy and what we do not want. We currently don't have that granularity right now. And as he said, maybe looking at more sector-specific analysis would be needed to dive deeper into these solutions. But those are my reflections for now.
Thank you. Would either of our other panelists like to add any thoughts?
Yeah, I would like to add that I think it is very important. In order for us to make progress in upstream, we really need to address a lot of problems that exist today that are barriers to implementation of circular economy for existing product. If we don't make that part work, there will be less incentive for doing more work upstream to address, circular economy from a broader point of view to get more benefit. But in order to get there, we really need to address a lot of the existing challenges for marketing circular product, for ability for us to make economics for circular product work. I mentioned the challenges in trade. For example, if we can't get the core, which is end-of-life product, moved to facilities, there's economy of scale. So if we can't move this end-of-life product across borders to where we have a facility that can actually manufacture those products, the economics will not work. So in order to, and again, if there's no business development in this area, there's no market development in this area, nothing will be there to incentivize organization to do work upstream to facilitate higher, level of circular economy implementations.
Jeff?
Yeah, if I might, it's really interesting, and I agreed with Mr. Yamaguchi. The question had me thinking for a while, but I think it's important to recognize the point of the question, which is that we can't just think about designing a product and then recovering it end of life, because most products go through an entire value chain, working with service sectors, updates, recovery material along a supply chain. And each one of those stages not only does something working with the product or adding to the service, but also has their own supply chains in behind them and are accessing materials and maintaining factories or using land or accessing other resources that become part of the overall footprint or circular impact of that material. And if we don't think of how to follow along and increase the transparency and traceability of all those additions along a value chain, we're going to miss a lot of the impacts that we're trying to capture. And so really it gets to a question, I think, of how do we improve traceability and transparency measures to make sure that we're understanding additions to the footprint, material implications, environmental outcomes of each stage along a value chain, instead of just designing the initial design of a product and then the end use. Which suppliers you use, which who you work with along your entire value chain is going to matter for what the circular outcome looks like. And then thinking again about if you're accessing and trying to make decisions about blending secondary material in your production cycle, how has that material been used previously? Where is that accessed from? These are things we don't have good data or information on. And we need to think about improved traceability and transparency measures that will allow us to better inform those decisions.
Great. No, thank you all. That's really helpful. And I think, certainly gives us additional, in addition to the many questions that you each kind of posed throughout your presentations, that gives us even more to think about on this really interesting topic. So Daniela, did you have a question?
Thank you very much, Kelly, and thank you very much to the excellent presentations. I think we just made a point of the importance of the expertise for well-informed, how important is expertise for well-informed policies, science-based informed policies, and we had experts in trade, engineering, public policy, economics in such a complex issue that just certainly requires this reflection. So it was a certainly great presentation. So I have a question. It's not. I hope it's not a complex one, but we all recognize that we need to move towards a lower carbon and more circular economy. This will result certainly in haves and have-nots internationally, with the gap potentially widening between developed and developing countries, and impacting disproportionately certain and communities, underserved communities, vulnerable communities that have been impacted also by by climate change. So how can trade officials, how we can support more environmentally sustainable as well as equitable clean energy transitions, clean and safe energy transitions? And that's my question to you three. And thank you again for the excellent presentations.
So I might start this question
Thank
here.
you, Nabil.
Answer. Okay,
Please go
can you hear
ahead.
me? Yeah, so I think it's a great question. I personally believe that many of the low carbon technologies, for example, and many of the technologies that we use in this area would have significant impact on countries that have lower income, for example, for a variety of reasons. Among them is the fact that, for example, I'll give an example of aluminum, for example. When you use secondary aluminum or recycle aluminum, you use significantly less energy, probably 75% less energy than the production of virgin aluminum. So this is a low carbon technology. This has a significant impact on the economics and also on the availability of material, for example. I argue that many countries that actually have legacy technologies, it's harder for them to make the transition, and many countries that are developing their own industrial enterprises would have easier time actually implementing many of those technologies because they don't have the legacy technology to deal with. On the other hand, I think the key here again is that we need to make sure there is sharing of technology in this area. So there would be no have and have not. It would be really benefit everyone. And this is really an area that, especially when you talk about circular economy, you're dealing with processes that have low capital equipment investment, and it has significant economic value and also employment. So I think the more we push in this direction, I think the better it is, across the board. So anyway, so I think that low carbon technologies, for example, that are developed, I think has great potential in many countries that today are developing their industrial enterprises.
Thank you very much, Nabil. And certainly technologies, technology, the sharing of technologies is a key part of this area. Thank you very much. Jeff, do you want to go ahead or shouldn't I?
Yeah, thank you. I was just, I was pulling something up and I think I missed. So can I just clarify? The question was about, you're related to whether the transition will create have or have nots versus emerging economies. Was that was the focus?
I was talking about, yes, trade haves and have-nots, but also widening the gap between developed and developing countries, and how we as trade officials can address this situation for a clean and safe energy transition, but that can benefit all in terms of development in all its dimensions, I can say. Thank you.
Yeah.
Before you jump in, Jeff, I would just note that we also received a question from the Zoom, which is really very much related to this question. And so perhaps, adding that into the conversation would also be of benefit. But so let me just add that, and then you can, I think, answer both together because they're related. But basically the question that we received from a participant on the Zoom is that, it seems there are lots of problems about access to technology, rare earth materials, know-how, supply chains, even from advanced economies. So what could developing countries do to overcome these difficulties? or are there any priorities that the presenters think we should focus on? So this came from a developing country, a participant on the Zoom. So just to add, I think it's a related question. Thanks.
Yes, thank you. Sorry to ask you to repeat the question, but I just wanted to make sure I caught it correctly. I was thinking about this in advance and a few things to raise. And I agree with the points that Dr. Nasser raised, that there's a lot of opportunity. And some of the questions that we're asking relate to how will those opportunities translate into livelihood impacts on folks who are upstream. So if you take the premise of my presentation, which is we're going to continue to rely on primary resource extraction along with secondary material access and increasing circular practices along value chains, you have to then start to think about, well, what does primary extraction for circular value chains look like upstream? What changes in practices is it going to require for primary resource producing economies, many of whom are located in the global south? Most resources are located. If it looks like increasing transparency, traceability, certification of materials, and understanding environmental impacts, what impact is that going to have on groups like artisanal small-scale miners? There's a really good report from the African Circular Economy Alliance, which highlights that there's about 42 million, I think, is their estimate of the size of the ASM sector globally. Sort of 80% of that is informal. What does integrating these informal workers into a circular value chain look like? Are there opportunities for them to participate because they can extract materials from waste and tailings in areas where it's more difficult for large-scale mining operations to do so, or are they at risk of marginalization? And I think this is a question we're asking, and is one that's worth examining further along different value chains, not just in metals and mining, but what does integration of the livelihoods of workers upstream in value chains look like if they're integrating into more circular value chains downstream? I think another really relevant question from a global trade perspective is just thinking through whether there are additional governance mechanisms globally or governance approaches that we should be thinking about. So again, I apologize if I get this wrong. I'm not an expert, but my understanding of WTO is there's certain principles that underlie WTO rules like non-discrimination, transparency, and traceability, things like that. But do we need to think about different principles to sort of govern the flow of resources where resources are extracted is going to become increasingly divorced from where they end up being used and recirculated repeatedly over time if we move more and more towards a circular economy? If we look into the future and we see, the US and China, which currently do, but are also big consumer markets, and the EU increasingly looked also as resource producers because they're largest consumer markets and they're recovering greater volumes of material in circular processes. What does that mean for upstream countries who were original resource producers? Are countries sharing, trading and providing access to these recovered materials? Are we seeing increasingly closed domestic agreements to try to hold on to critical and strategic metals that don't enter back into global supply chains? Or even outside the country context, are we seeing large corporations extracting resources, putting them into their own battery EV supply chains, for instance, really only renting out those vehicles, recovering the batteries at the end of life, circling them back through their own value chain, and never having them again re-enter back into the broader economy? So I think these are questions we should think about from a global governance perspective to set the right frameworks for how trade proceeds in a future where resources aren't just mined, extracted, used, and then discarded, which could be thought of as made available again for use if you could access them, to where they're extracted, used, recovered, used again, recovered, used again, and what are the right frameworks for that to operate in?
And Shunta, did you have anything to add?
Yes, thank you very much, Kelly. I'll be brief, and it relates very much to my previous two panelists, but I'd like to raise 2 points, perhaps. The first is that developing and emerging economies are often suppliers of primary materials, as Mr. McCartney just referred to. And from our analysis, we see that if there's a global transition to a circular economy, production bases and export bases seem to become more specialized. And therefore, because of this, a circular economy transition might negatively affect a few economies or a few countries. But at the same time, the low carbon transition requires a lot of materials as well, as we've seen from the discussions today. And therefore, how to secure the environmentally sustainable and just transition for the extractive sector is absolutely necessary. And this can also be an opportunity for these countries that have these sectors in place. The second point I'd like to raise is that there could also be new and emerging opportunities to tap into circular business models and circular value chains. And the circular economy transition can offer managing materials better in our economies, how to manage them better end of life, how to supply them in a circular way. But this really requires some kind of reference, such as what would qualify as a circular product, or what would qualify as a circular business model. So we need more work in setting those, and also working with these economies that have opportunities in place, so that they also come together as we go forward. So I'll stop here.
Okay, I wonder if we have any questions from the floor. Yes. Madeline.
First, thank you very much for this extremely interesting session. There was one thing that stuck with me. I find it very interesting to, as Kelly, as you say, to look not only at the end and the beginning, but also what's happening in between. But one thing stuck with me is the presentation where you say that the solar panels generation 1 are overtaken by solar panels generation 2, and we're actually dealing with totally different materials, which puts maybe in perspective your in-between question, what is relevant for trade policy? Because the takeaway is that actually we're in an extremely dynamic world with technological developments, and that would be interesting to know how we do that, because if you develop even a best practice or a rule for trade, it takes a long time. So how do we deal with this rapidly changing inputs to technologies? And actually the second question, this morning we had a comment on the role of tech transfer. But you have an eye-opening, not that we were not aware, but the presentations were extremely interesting in the sense it's not just transferring the technology of an beautiful solar panel to another country, and there you have your solar panel. It's a whole supply chain that comes along. So I think it puts into perspective the emphasis on technology transfer to actually something that is a much broader integrated issue. And what is your view on that?
Were you directing that to all the panelists, or?
The one who finds he or she has the best, no, it's all he's.
It's all he's.
Has the best answer. The gender balance is on the other side with Daniela and Kelly.
That's right. Shuta, do you have any thoughts?
Yes, maybe let me quickly kick off, but I think other panelists might have better reflections to this. So on this dynamism and how to cope with the emerging context is a very important one. And what we've been discussing today, to my mind, I think a lot of reaction to current developments is, since we don't know well, let's close the door on trade. We don't know if it's good for a circular economy, or we don't know if it's bad. Then let's just stop trade. And I think that's been sort of the trend that we've seen, for instance, in the Chinese import bans or the Basel Convention amendments, which is for a good cause, I would say. But we would also want to question, are we closing doors on trade too early if we have these emerging contexts and if we want to cope with this dynamism? So that's the question I would have. I do think there would be a role for trade. And how to carefully do that is what we're trying to discuss and go forward. Let me stop here. I think others might have better answers as well.
Yeah, I'm happy to
Jeff,
jump in.
please feel free to jump in if you'd like.
Yeah, thank you for the question, and thank you for that. I thought that was a good initial response, and has me thinking about it a little bit more. But just in response, yeah, highlighting the point that you raised about different material requirements. It's important to note that it's, material requirements are higher across a range of renewable energy technologies. It's not just solar and wind, but it's also biomass. It's also hydro, nuclear. EV cars are more material intensive than internal combustion based vehicles. And you increase material use as you switch to renewable technology, and also as you switch sub-technologies within those classes, right? So different wind production technologies, different solar. And it's not necessarily radically different components, but some of the core components do change. And I think it's where I think it really highlights the importance of trading relationships in trying to look at, regional requirements and what, the energy production needs of different regions are, what material access among reliable trading partners in your region looks like, how that might help inform both strategic adoption of particular technologies, but also strategic investments in developing capacity to recover and reuse the materials that you are importing in those technologies as you install them, so that you have more reliable supply chains going forward. And I think that the technology shifting, the dynamic nature of it just really highlights the fact that we're going to rely on trading relationships and reliable partners to access the resources. We can't, firmly predict exactly what we're going to need. And it's unlikely that any individual country is going to have all the materials that they require. Even if they have a large basin sector, if you shift technologies, you could be shifting the material requirements that you're looking for. And one other point I just want to pick up on, I'll be really brief, is you highlighted the supply chain challenge. And what I want to point to is we move to an increasing circular economy, you have to add on to that supply chain a whole waste management chain in behind that to make sure we're not only producing and installing and implementing the technologies right, but then recovering, collecting, reusing, aggregating, and redistributing. And those aren't trivial challenges, and they're going to need to be thought of, I think, in a regional basis and across borders.
Great. Thank you, Jeff. So we're running short on time, and I kind of wanted to do a quick speed round with the panelists on one particular question before we just turn to very brief closing comments. And I think, each of you mentioned various trade-related policy recommendations or questions that you highlighted that should be asked and answered by governments and others. And I guess one thing that I'd like to maybe do a speed round on is if you had to pick just one kind of trade-related policy recommendation that would have the greatest impact on these issues of, circular economy and climate change solutions, what would that be and why? So maybe I can put you on the spot first, Shuta, since you're right next to me.
Yeah. Yes, thank you, Kelly. I'll also try to be very brief. This one, I think stepping back and trying to highlight the role of trade or the potential role of trade to enable a circular economy transition is the thing that is necessary, because some policymakers, for instance, at the domestic level, there's still some belief that circular economy is something domestic and it should be like these materials and products should be circulated domestically. And the role of trade is not really highlighted at that level. So like some kind of principles or trade-related principles coming out from a trade lens could be important. And then there are, of course, some subcategories such as trade and environmental goods and services that we can pick, or some other areas such as reinforcing existing mechanisms such as prior informed consent procedures. But I think we need some more high-level messaging here.
Thank you. Nabil.
Yeah, well, I think if I have to choose one, and I have so many that I would like to see changed, but one of the things that we struggle with is that the fact that the definitions of the categories of product, it's either labeled as new or used, and many countries ban the use of the used product from being imported, and from a circular economy perspective, we consider the true product that meet the same condition as new, that remanufactured product meet the same specification as new products. So if there are change in policy that allow for this product to be treated like new product, as long as they meet strict standard for that, that would make a huge difference in expanding the volume of remanufactured, for example, refurbished product around the globe. Just a very quick comment, the intensity of some of those remanufactured product in a specific sector is in the 2% range. And the chances for us to actually go to a much higher level is there. It was that change in the trade policy side.
Great, thank you. And Jeff.
Yeah, thank you. I agree with Dr. Nasser, but maybe to highlight something different. I'm not sure if you would qualify this as explicitly trade policy or not, but we need better disclosure standards for material composition of goods. And if we don't know what's in a good and what its background footprint is, we're never going to be able to refine the classifications sufficiently to enable decisions for more sustainable products to be made. And so we need to improve disclosure standards and requirements to not just label new or used, but understand where the material is sourced from, trace it back to supply original sourcing, and understand the broader footprint of the materials we're using.
Great, thank you. And with that, I think we've run out of time, but I think both Daniela and I would like to make a couple of closing remarks and thoughts. So maybe Daniela, if you'd like to start us off.
Of course, no, and thank you, Kelly. It has been great to moderate this panel with you. And again, thanks for the great presentations. It really highlights the importance of science-based informed policy to deliver solutions that are environmentally sound, but that supports supporting a low carbon transition, but also that delivers safe and innovative products and services, including technologies. And we have listened about the importance of technologies being and the transfer of technologies being transferred, investment through investment or other tools that can indeed deliver access and development of innovative technologies to ultimately reduce materials. I learned today the number of metals that are used for different products and sectors. So that only highlights the importance of understanding sectoral approaches. I think it was one of the things that I picked from the conversation. It could be good to conduct deeper sector analysis and even product analysis. I would love to see to understand in one product the whole supply chain, but also understanding the whole life cycle and where trade interacts, when trade solutions interacts. And well, financials, regulatory, technical barriers, transparency, regional ecosystems for innovation, production, and competitiveness are important things to developing countries and developed countries. So that's, I think there is common ground on that. And of course, net zero goals, but also understanding the health risks associated. You panelists talk about good and bad products. So I think that conversation is a good one to overcome certainly some a lot of questions around what safe circular economy, and certainly understand clusters and solutions around it. But certainly I picked innovation is one of the things that I would love to understand more in terms of every sector. I will stop here, but I was delighted to listen to the experts, and certainly I think engineering is one of the things that we need to include in the conversations to understand this particular issue. I'm looking forward really to talk more about this. Just to mention one specific thing I'm forgetting, strict standards, one of the things that was also highlighted, certainly one trade-related aspect as well as other aspects in terms of international trade. So thank you very much, Kelly, and thank you very much to all the panelists. I think you also wanted to mention some of the things, and certainly we will keep talking about this aspect. I wanted to also highlight the important work that the TSSD is doing in this regard. I see Canada, but also Chile here conducting an amazing work, and Cass from Japan. There is a conversation going on in terms of circular economy and circularity in the TSSD, and certainly we look forward to work closely. Just wanted to add that to the remarks. Thank you, Kelly.
Oh, great. Thank you, Daniela, and for hosting this together as well. And just thanks again to everyone for joining us, and most especially to our excellent panelists who really shared with us today some very important insights and visions on this topic. You've also posed to us a lot of really important questions that we need to grapple with, and hope that we can move that conversation forward here together with other WTO members. So a couple of main takeaways for me, clearly we will need a lot of increasingly scarce resources to produce the technologies that are going to be critical to help us reach our climate goals. And so therefore, circular economy approaches, including when applied to these technologies, can increase efficiencies, keep them in productive use for longer, reduce their life cycle greenhouse gas emissions, as well as the need for primary material mining or extraction. And so it seems, this in turn will support improved environmental sustainability and benefits across the value chain. So really, again, a very important conversation that we've had today, and really feel that we've just scratched the surface, and there's a lot more to dig into. So thank you, and looking forward to the longer term discussion that we'll have amongst us on these really important issues. Thanks. Thank you.